Hi, this is Mrs. Lemke, and I'm going to walk you through the first set of SAT practice questions that we had. These were the non-calculator questions. I'm not going to go through all 15 problems. That seems like it would be a little tedious for everyone, but I do have slides here that show the correct answer on each problem. So if I don't go through a question, you will be able to look at this, look at the question again, see the correct answer. You can pause the video and take a look at that question and try to figure out how to achieve that right answer. If you're not sure about that, you certainly can send a note to or an email to your teacher and just say, hey, I'm looking at, question number, 7 or whatever, and I don't understand how to get the answer of, 24 times 1.162 to the t, or whatever it might be, right? And then your teacher will certainly be responsive about that. I'm just going to go through the ones that were missed by a great number of students. Okay, so question 1 in my numbering, and understand that the questions came up in different orders for different people, but question 1 in the numbering has this solution that's marked with a smiley face. You can pause the video if you need to look at it more closely. This question is one of the ones that I'm going to go through. So it says in the equation above, T represents Brittany's take-home pay in dollars for her first week of work, where H represents the number of hours that she worked, and 1,000 represents a sign-on bonus. Now the sign-on bonus, she's just going to get that one time. Like she just got the job, they gave her $1,000, like a flat amount. And then it said that H was the number of hours that she worked. It's like if she worked 22 hours, then H would be 22. Okay, and so that's for the hours that she worked, and her take-home pay was 1,576, and we want to solve for H. So in other words, you're going to put this number in place of her take-home pay, because that's what it said it was. And we're solving for H. Okay, so it seems to me like she's getting $18 an hour. It's not bad, right? Good job. Good job, Brittany. Okay, so subtract 1,000. And then to solve for H, you'd have to get rid of the 18, so you would be dividing by 18. Okay, and when you take 576 and divide by 18, you do indeed get 32. Okay, question 3 was not missed by a ton of people, so I will just let you look at that. You can ask your teacher if you are confused about this question. Feel free to pause the recording. Here's question 4. This also was not missed by very many people, so good job on that. This is just a solving problem. You would need to distribute. Be careful about signs, and then just solve for x, isolate the x. Question number 5 was a commonly missed question, and my guess in that is probably we had sign issues because this is a little tricky. So they gave us a function, and they wanted us to evaluate that function at x equals -1. So f of -1 means you put -1 in place of all of the x's, like I'm doing right here. And then we need to be careful about signs. So -1 times -1 times -1 is what this part means. And that is itself -1. -1 times itself becomes +1 times 3 is +3. Here's the one that I would personally trip up if I made a mistake on this. -6 times -1 is +6. And then the last piece has always been there, subtract 1. So if you look at the positives, we have 9, and then we have -1 and -1, so that's -2, for a total of 7. I would guess that there's just some sign issues there. I think you know how to do that. All right, this question maybe is easier if you have had a geometry class already, and for those of us who have not yet had geometry class yet, this one's going to be a little bit of a stretch, okay? That's okay. So if you have geometry to look forward to next school year, you can look forward to more questions like this one. Okay, so let's just work through the words here. It mentions we have 2 triangles that are what are called similar triangles. So similar figures are figures that are like scale models of each other. So if you think about like a model airplane and a real airplane, Those would be similar airplanes. Everything is in proportion. So the sides are proportional and then the angles are the same. So that's what makes something a model, is that it looks exactly like the real thing. It's just kind of shrunk down. Okay. So we have two triangles that are called similar. So one's like a smaller version of the other. And then segments AB and DE correspond. So those are the ones that are like matching up in proportion to each other. And it mentions over here that DE, the length of side DE, is twice the length of AB. And so I wanted to keep reading until I got to that part because I didn't know which triangle to draw, bigger or smaller. And that tells me that DE is the bigger one. So I'm going to make this triangle ABC. And then I'm going to make another triangle. I'm going to try to draw it like kind of twice as big, or at least bigger. Okay, and then it said that AB and DE were the corresponding parts. So at the same like location that I have AB, I'm going to have DE. And that makes this side F. Okay, and then it says that the perimeter of triangle ABC is 20. So when I add up these three sides going around, I get 20. That's what perimeter means, adding up the edges. And then over here, it's wondering what the perimeter of this shape is. If I add up the sides as I walk around the shape, right? If I just took this length plus this length plus this length, what would I get? Well, it did say up here that this side DE is twice as long as this side. And because the shapes are similar, that means everything is proportional. So whatever the length of BC is, EF is twice as long. And whatever the length of CA is, DF is twice as long. So if every single side of the small triangle is doubled, that means that the perimeter is doubled also. So the perimeter on the small triangle being 20 tells me that the perimeter on the large triangle has to be 40. That's a big time reading question, I think. Okay, this next one, people got very correct. I was super excited about that because we just did a unit kind of like this, where we did exponential growth. Question number 8 was not missed by very many people at all. That's fantastic. All right, this question, also not missed by very many people. I'm very excited about that. This is our basic parabola, and we want to know what happens when we add 3 to it. That slides it. Okay, this question again, I think maybe was hard because some of you haven't had a geometry class yet. So let's take a look. First of all, they did point out that the picture is not drawn to scale. So we can't use the idea of, oh, it looks like. That's not an argument we can make, okay? So in the figure above, it says that AE and BD are parallel. So these two line segments go straight across and they don't touch each other, right? So lines that are on a flat surface can either cross or intersect, or they can be parallel and not intersect. That is only true on a flat surface like your piece of paper. Okay, so in this we have parallel lines, and it says angle BDC. So I have to figure out where that is. BDC. That angle. So see how I read that? The letters in order tell me where I'm talking about. So angle BDC is 58 degrees. And then it said angle ACE. So I'm going to read that. A to C to E measures 62. And then they want to know the measure of CAE. CAE would be this angle down here. Okay, so there's a lot at play here. One of the things that you might know from your earlier schooling is that the angles in a triangle have to add up to 180 degrees. So I want to take 62 and 58 and add those together. And then I want to subtract that total from 180. And that tells me that this angle here has to be 60 because of this little triangle. Those three angles have to add up to 180. Then something else that you might know either from geometry class or maybe from like middle school is that if I have parallel lines, then these two angles have to have the same measurement. And that's present in our picture right here. Here's the line that we would call transversal. Fancy word, not necessary to really have that, but this angle being 60 means that this angle is going to be 60 because the parallel lines keep everything kind of matching up. So this is our correct answer for that question. Again, I have a suspicion that that might be just haven't had as much geometry. Okay, this question we do need to take a look at, and it just asked us to look at this equation, and basically it boils down to just solving for the other variable. And so I think maybe some people may be freaked out because they thought they needed some sophisticated understanding of things. And really, it's a question where you just have to like see that it's already there. So it asked, which of the following represents the period of the wave in terms of the speed of the wave? And earlier in the question, it said that the speed of the wave was s, and p is the period of the wave. So if we read that last question, the part I have in purple, it's saying which of the following represents p in terms of s. So I just want an equation where p is on its own and then it's like blah, blah, blah with s in it. Well, I have an equation that's kind of the reverse of that. I have s equals blah, blah, blah with p in it. So I just want to solve for the other variable. So given that I have this to start with, to get p by itself, one possible way to think of this would be I'm going to multiply by 2/3. And that would come to my head because this number times this number are going to equal 6/6 or 1, which would give me p by itself. Now, if that didn't come into your head, another way that you might have thought about it would be to say, all right, I started out with s equals 3/2 times p. Let me divide both sides by 3/2. Then this number cancels this number. And when I divide by a fraction, that's the same as multiplying by the reciprocal, which would give me that, right? Dividing by 3/2 is multiplying by 2/3. All right, this next question people did very well on. That's just testing to see if you know slope-intercept form. Also a little tricky in that you had to notice that this was a 2, so the x-axis is counting by 2's. This question, a lot of people got right, so I will just let that be. That's a pretty hard geometry question, but I don't know, somehow you guys got it. That's great. We're going to talk about 14, but before we do that, I'm going to show you number 15. Number 15, I thought we would have to go over, but a lot of you got it right. I will just make a short mention of it. This is the question that you were given, or this is the equation. If you isolate for y, or solve for y, you have this, divide by b, and you have this. So this one here tells you that it can't be c because it doesn't have a y-intercept of 1. The other lines all do, but it comes into thinking about this slope and the fact that a is smaller than b. So you know you need a negative slope, and you know that you have to have a slope where a is smaller than b. So just try out these 3 graphs and you can figure out which one it is. Okay, number 14 is one that we should talk about. Number 14 said, which of the following is equivalent to that expression? Well, the x squared plus 8x plus 16 that's inside the radical can be factored to that. So when I have my whole expression, the 4th root of that, another way to write that would be to say the 4th root of x plus 4 squared. And you know that a root and a power can be written as a rational exponent. So x plus 4 to the 2/4, the root goes on the bottom, the power goes on the top, and 2/4 is the same as a half. So there's our solution. All right, I hope that was helpful to you, and I wish you all the best.